Hey everybody, welcome back to the final video for Unit 2 of Chemistry. This is going to be a recap video. If you haven't seen my other two videos in this unit, please go check them out. They're posted to my YouTube. They're more of in-depth explanations of things we have already discussed in class. But like I said, this is going to be a recap video and just touching upon some of the ideas that we discussed in class before the upcoming unit test. So here we go. Remember your three laws, the Aufbau principle, the Pauli exclusion principle, and the Hund's rule. Basically, the Aufbau principle means that electrons fill the lowest energy orbitals before moving to higher ones, so you can't fill the p orbital before you fill in the s orbital. The Pauli exclusion principle means that no two electrons in the same atom can have the same set of four quantum numbers, and the Hund's rule basically means that in an orbital diagram, you are going to fill in each box once before you fill in each box with the second electron. I hope that makes sense. So now we're going to be discussing valence electrons. Basically, each compound, or each element wants 8 electrons. That's like the stable number. And in group 1, we have 1 valence electron. Group 2, we have 2 valence electrons. 13, 3 valence electrons. 17, 7 valence electrons. And 18, 8 valence electrons, except for helium. So basically, atoms gain, lose, or share valence electrons to achieve a full outer shell, usually 8, because this is the most stable number, and this drives chemical bonding. In ionic bonds, they transfer electrons, and in covalent bonds, they share electrons. And valence electrons are only on the outermost shell of the element, or the atom. Remember to the Bohr model, valence electrons are going to be on the largest n level. So if you have an atom with 4 n levels, the valence electrons are only going to be on the n equals 4 shell. All of the other electrons are going to be called core electrons, and they are n equals 1, n equals 2, and n equals 3. So here we have some practice problems. These are going to be on the next slides. Make sure to pause the video when I read the problem, because I'm going to be going through these a little quicker. So pause the video so you have time to actually complete the problems. Same thing with the answers. I'm going to be flying through these pretty quickly. So write the electron configurations for scandium and copper. We're reviewing electron configurations right now. Remember to pause the video. Here are the answers. You should get something like this. Shorthand electron configurations. Write the shorthand electron configurations from tantalum and gold. These are the answers. And now we have orbital diagrams. Draw the orbital diagram for fluorine and magnesium. I do not have the answers for these. You can easily just search them up yourself, since it's pretty difficult to get an orbital diagram on Google Slides. I also have to study myself, guys. Sorry. Formulas. Remember how to use the formulas involving frequency, energy, wavelength, and change in energy between n levels. Remember the constant over n squared, and then subtract those to find the change in energy. But yeah, just make sure you know how to use the formulas on the back of your formula sheet, and you should be set for this upcoming test. So good luck. Make sure to check out my other videos, and please subscribe if you haven't already. And I highly encourage that you enable notifications on my YouTube channel, so you get notifications whenever I post a new video about physics, chemistry, whatever class I typically tutor in. So thank you so much. And again, also send this video to anybody else, so we can get this out there so everybody can do good. Yeah, thank you so much. Good luck.